Okay, welcome, Amara and Izzard and Amberly this is the first regular statistics webinar. Orientation is very different than this one because in this webinar, I'm actually going to be talking about statistics. And the plan is to go over the highlights of chapters 1 and 2 because that's the first week's material. They're not the hardest chapters. And that's why I do 2 chapters in 1 week, because there's some weeks I have to do 2 chapters. Most weeks we only do 1. But chapters 1 and 2 are introductory chapters. A lot of it will be review for you, and some of it might be new also. So that's the plan. Before I start, though, I want to ask you, are there any questions that you might have about anything? Give you a minute or so, because again, one of the big points of the webinars is for you to be able to ask your questions live and get them answered. Any questions? Okay, so if you have any questions throughout, let me know. I'm gonna have you participate sometimes. I thought I'd get started by talking about something that happened this afternoon, and that's what I love about this class. None of my other classes I can tell you what happened this afternoon and have it relate right to what we're doing, and this one really does. So I don't know, any of you, I don't think are any of you in Tahoe? Were you on campus today?
I'm in Tahoe, but I wasn't at the campus today.
You weren't on campus today. Okay, on campus, I walked by campus, and they had this guy, where is it? I put it somewhere. Somewhere, but they had voter registration. So I talked to him, and I knew it's a small town, and you know how it is. I knew everyone. So I knew the people at the table, and I chatted for a moment. And they're going to be hosting a forum for our county supervisor election, which is happening in June. So that's in the June election. And they wanted some advice on how they can figure out who to endorse. Okay, that's pretty important, right? Because, you know, there's the 3 people at the table, but they shouldn't be the ones deciding who to endorse. And just like, you know, this was the Democratic Party. Again, I don't tell you how to vote, but I tell you about how to understand how to gather information statistically to figure out how to make informed decisions. And that's what this class is about. So what they chatted with me about is they want to figure out who to endorse, and they're going to be having this forum with a lot of attendees. And the question is, how do they figure that out? Okay, how do they figure out who the right candidate is to endorse amongst the candidates that are going to be running for County Board of Supervisors? Okay, and wherever you live, you should always vote. That I can tell you. I won't tell you who to vote for, but I will tell you it's a good thing to vote if you're a citizen and not a felon, and you know all the things. You're over 18, the things you need to do to vote. And but also it's important that the Democratic Party or whatever agency it might be is endorsing the right candidate, the candidate that their people want to vote for. So a couple things we looked at. The first thing is we had to identify who the population was. So in chapter 1, a big part of it is to really talking about how do you identify the population, and then how do you identify a sample. So the population are all the people you're interested in. Now in statistics, it doesn't always have to be people. Sometimes like a biologist might be studying monkeys or something, and then it won't be people they're interested. It's the monkeys they're interested in. Or maybe it is weather, and they're interested in days and what the weather is on that day for all the days over the last 100 years or something. But you have to identify the population, and that's really important. And that could be tough. And I'll be honest, and I guess I'm public here. I helped them on that identification because they needed help on that. And I let them know if they're the Democratic Party, then they should probably be surveying Democrats, because that's who their population is that they're going to be endorsing for, is for the Democrats that are part of the Democratic Party. They should be looking at what the Democrats think or who the Democrats think is the right person to be elected. for County Board of Supervisors. And by the way, this could be for any particular political office. Board of Supervisors is the one they happen to be talking about this afternoon. Okay? And in fact, not only do I know statistics well, but I know politics really well. Okay? For a reason that you may not know yet, but I was a politician for 9 years. Okay? I was an elected politician. I'm not sure, Nizard, how long you've been here, but you might have voted for me. You don't have to say you voted for me or not. You may not even remember.
I've been here for on and off 12 years.
Okay, so I was on the ballot and I did win twice. So.
Oh yeah, you did.
Uh-huh. Yeah,
maybe,
I won. Yeah. What's that?
So maybe I did vote for you. Who knows?
You might have voted for me. You just don't remember. I was on the school board.
Oh, okay.
So I know very in depth statistically and also as an insider, is that I understand politics. So the next question we had to think about is, all right, well, how are they going to find out who they should endorse? And what you really want, is you want to find out their population should be all the Democrats in our voting district. That makes sense, right? So that would be the Democrats, if it's the County Board of Supervisors, that would be the Democrats in El Dorado County. So if you don't know, you don't take notes on this, but Lake Tahoe is in El Dorado County. So that was our population, and there is no way between now and June, okay, and not even now in June, really now and the end of the month probably, that they can figure out every single Democrat who they think is the best person to be a county board of supervisor for our area. Does that make sense? Okay, and maybe our area might be the population. So you can't survey everybody because you can't get a hold of everybody. Does that make sense? There are like 10,000 people that you would have to get a hold of, and that's way too hard to do for a small volunteer group. Is that clear? So here's what statistics is all about. It's all about figuring out how to collect a sample from the population, because you can't get the whole population, and then survey that sample, look at the results from that survey, and then decide what the results mean. Okay, and that's this class. Okay, that's a summary of everything we do in this class. Okay, there's going to be, of course, a lot of details. If that was, all the details, then we'd be done with class. But there's going to be another 11 and a half weeks of this class. So, but that's really what we're doing in this class. We are trying to figure out how to best collect data to represent the population when you can't get the whole population. Okay, any questions on that idea? Okay, so now that we needed to make sure that we got a sample, let's suppose we could get a sample size of, maybe 100 people might be all we have time to ask, okay? Which is not a huge sample size. Then there's a lot of things you have to do to design the study. And chapter 1 is all about how to design a study. So the first thing, one of the things you have to do is you have to identify who you're going to ask. So you're going to have to identify who you're going to ask. And there's lots of ways of doing it. The easiest one is you ask your friends, the people that are willing to answer your survey, and find out who they want. Okay, your friends who are Democrats, I guess. And anyone know the problem with that? What's the problem with asking your 100 people around town who you want to vote for?
This could be biased, right?
Yeah, it's going to be biased, because then what's going to happen is you're going to be asking people that are probably like you. Okay, your friends tend to have a lot of the same personality traits that you have. Similar age, similar gender, similar race. Okay, it doesn't mean that all of your friends are the same race and gender, but you're definitely going to have bias that way. Okay, so that type of sampling is called a convenience sampling, because you just do whatever's convenient. Okay, it's not a good way of sampling if you want a representation of the population. If there's anything you don't understand that I say, please say something and I'll help you out, by the way. Okay, the goal is to represent the population. The easiest is convenience sampling, and it's the worst. So that's the bad news. Is the one you want to do because it's so easy you can't really do and get good data. So there are other ways of getting getting a sample besides convenience sampling. Any suggestions? Any thoughts on how you might get an unbiased study? Okay, or at least not completely unbiased, but limit the bias in the study. And bias, by the way, means that the results that you get are not going to be what the population has. It's only what the sample has, and the sample is going to be different than the population. So, for example, if you want to find out the proportion of people that want to vote for Sue Novosel, she's running. Well, if it's likely that the sample is going to have a higher percent than the population, then you have bias. Okay, so if you can identify that it's going to be on the high side because of who you asked, that'll be bias. Or if it's on the low side, it'll be bias. Okay, if you have a special group of people but it has nothing to do with whether they want to vote for Sue Novosel or not, there's not bias even though they're special. So bias means that that group is not likely to have the same answers as the population for the survey question you're asking. Any questions on that idea? Okay, so how might you limit bias? Any thoughts? And then I'll talk about some of the standard ways.
Random sampling?
Okay, random sampling. Okay, so that's actually the best way of doing it and the hardest way of doing it. So the good news is you're right. That is the ultimate way of limiting bias, is random sampling. But here's the hard part. What does random mean?
You just choose a group of people by, I don't know.
Like no pattern or no.
Yeah, how do you make that happen? Exactly. So here's the only way to make it happen. There is only one way. And that is you have to obtain a list of every single person in the population. Then you have to use a computer. There are other ways besides a computer, but no one does anything but computers nowadays. And you have the computer generate 100 people from that list. And then you ask those 100 people and you make sure that they all answer your survey. Okay, that is very hard. Okay, so the first thing is, and this is an interesting one, do you think it's possible to get a list of every registered Democrat in our county?
No.
The answer is yes.
Oh, okay.
The answer is yes. It is possible, and actually that's public information. Okay, but it's not that easy, but you can get it because you're dealing with bureaucracy, and dealing with bureaucracy is always hard. But yeah, no, you actually have the right to find out a list of when you register, your name goes on a list that you're registered. So that is actually public information. But then you have to make sure that every person that you ask is going to answer your survey question. That's not possible. It's also very hard to contact everybody. Just because you have a list of their names and their addresses, good luck trying to find them. Okay? Go knock on their door and hope they're home. Good luck. And then hope they'll answer it. Then when they think you might be a kook. Does that make sense? Okay, so random sampling is very tough, but it's not impossible, but it tends to be very impractical. Does that make sense? And it works for registered voters. It doesn't work for general population. You cannot obtain a list of everyone who lives in the county. You can obtain a list, it turns out, of the Democratic voters, okay, or the people who are registered to vote. But everyone who is in the county, you can't do, and then you can't get everyone to answer. So one of the biases, and I do want you to know this particular bias because it's the biggie. one of the biases that happen when you do surveying, almost in every case, not every case, but almost every case, is called voluntary response bias. So voluntary response bias, it means what it sounds like. What does that sound like it means if it's voluntary response bias? What does that sound like?
Answering voluntarily, or
Yeah, you're only going to get the people that are willing to answer.
okay, yeah.
And that type of person will often be a different type of person than the general population. Let me give you a really important example that happened 1.5 years ago. And what was the big, huge survey done 1.5 years ago that turned out where the results were completely wrong? And it was an American survey, that's the hint.
The election.
The election. So if you remember, okay, it was 1.5 years ago, and if you remember, what were all the news articles saying about the election in October 1.5 years ago? Who was going to win?
Clinton.
Yeah, Clinton. And they all said Clinton was going to win. Okay, what happened?
Trump won.
Voluntary response bias. That's what happened. So what happened is the people who tended to hang up the phone when they got a call from a surveyor were the same kind of people that vote for Trump. The people that tended to want to answer the survey were the people that were more likely to vote for Hillary Clinton. And so what went wrong was voluntary response bias. Okay, and these were professional surveyors. It is very difficult to avoid voluntary response bias. Any questions on that? So that's a big bias. Other biases that you can have that are easier to avoid are things like gender bias. So gender bias, hopefully you know what that might mean. Any guess?
Depending if it's a male or female.
Yeah, maybe you're asking too many women or too many men compared to the population. Does that make sense? So a gender bias is another kind of bias that happens in a study. But that one's easy. Okay, how do you deal with gender bias so that you don't have gender bias? Any suggestions?
Ask the same number of guys and girls.
That might work, but you can do better. I know here's something, and it's important actually. Let's suppose instead your population, because this is one I know a little more about, was students at our college, okay, at LTCC. What's wrong with asking, say, 50 men and 50 women?
There might not be, it's not split down the middle, the population of the students.
Exactly. Okay, you may not know it, but any guess? Are there more men or women in the college?
Women.
I think I heard both. Turns out there's more men. There used to be more women. And this is kind of a nice little fact. It'll be important for your projects. Any idea why there are more men now? About 3 or 4 years ago is what it all of a sudden changed like that. Now we teach prisons. We're the college for Northern California prisons. And whether you're a man and like it or not, there are a lot more male prisoners than female prisoners. And those prisoners, if they take one of our classes, then they are an LTC student and that counts. So that's why we're more men. Okay, there's just a lot more men in the prison and a big group of our students are prisoners. Okay, so we are actually about 54% men. Okay, that's a couple quarters ago. I haven't looked today, but something like that. So what you would do is not ask 50 men and 50 women. You would ask 54 men and 46 women. Do you see how that works? Okay, so this is what's called stratified sampling. Stratified sampling is when you identify a bias that occurs because of groups of the population. That could be gender. What other groups might have bias involved in it?
Race.
Definitely race. Race is another one where they do a lot of. Age is another one. Okay, they'll often stratify by age. Income is another one. you'll stratify by income because people in the upper class tend to be different than people who are in the middle and lower classes. So if you stratify by income, then you can guarantee that you don't have income bias. Okay, so there are many, many things that you stratify by. If you're let's say you're a biologist and you want to study the forest up here, you might want to stratify by ecosystem. So you might want to pick acres that are in, say, more meadow terrain and other acres that are more on a slope mountain terrain, and maybe study the wildlife or the biology in a representative acreage in your study. Does that make sense? So the stratification doesn't always have to be people. It can be in whatever you're doing, whether it is environment, it could be time. So for example, if you have a business, you might want to stratify by time. Let's say you have a restaurant, then lunchtime is going to be very different than dinner time in terms of the data that you're collecting. So if you stratify by time, where you first analyze how many customers you have in each time, and then you do your proportionate amount, not equal amount, but proportionate amount. So whatever percent are lunch customers, that's the percent of people in your sample you're going to be asking at lunch. Does that make sense? And same thing with dinner time, weekends, whatever, weekdays. So whatever it is that you are studying, you decide what might be the bias that could occur because you have overrepresentation of a certain kind of group. Anyone lost on what I just said? Okay. I know this is not feeling like a math class yet, is it? It gets a little mathier later in the last half. But it's chapter 1 and chapter 2. Any questions on stratified sampling? Okay, so there's steps in stratified sampling. The first step is decide what your strata is. The second step is do research and find out the percent of the population in each of the groups for that strata. Okay, so that might be if your strata was race. That would be first, is decide its race. Then you're going to find out what percent is Caucasian, what percent is Hispanic, what percent is African American, what percent is Asian, et cetera, what racial groups you're looking at. The next step is you multiply those percents by your sample size. So if you want to survey 500 people and you find out 40% are Caucasian, then you're going to take 40% of 500, which is 200, and you're going to establish that as your quota for that particular group. And then the next step is to go survey and make sure that you have identified your quotas. So you must get that number for each of the groups, and then you have successfully stratified. Any questions on the steps for stratified sampling? Okay, just one thing, and a lot of people have troubles with this for the project, for example, and other things, and the test. Stratified sampling is not the same thing as a comparison study. So if you're stratifying by gender, it does not mean that you want to find out if men are more likely than women to say something. It just means that you're making sure that your population, your sample, is representative of the population. Once you've done your stratification, once you've done your quotas, and once you've done your surveying, you have one list of data. You do not have multiple lists of data. Does that make sense? Because we will be talking about comparison studies, and that's different than stratified sampling. So comparing men and women is different than ensuring that you have the right proportions of men and women. Any questions on that? Now here's a challenge for you. Will you remember that in 11 weeks when you take your final exam? Because I gave a true-false question on the final exam 2 weeks ago. Any guess on how it went? It was brutal. It was brutal. Yeah, it was brutal. I gave a true-false question where I said stratified sampling by gender involves comparing whether men are more likely or less likely than women to whatever. I forgot what I said, but whatever it was, and that was false. Does that make sense? And it was miserable. Huh?
Stratify is not comparing.
Stratified is not comparing. So if you can take notes, that might be a good one. So I often test on that. Not always, but I often test on that difference. And definitely the project. A lot of you are going to do stratified sampling for the project, which is not a comparison study. Got it? Okay, there's another way of doing sampling that helps prevent bias. Your goal is always to prevent bias. And another way of preventing bias is called cluster sampling. So a great example of cluster sampling is done at the college. So, for example, let's suppose you wanted to survey Lake Tahoe Community College students, and I don't know, you wanted to find out how many units they were taking. Sound good? Okay. So, and you wanted to collect a sample of maybe 300 students. So one way of doing that is stratified, which we already talked about. But there's another way also, and that is called cluster sampling. So in that way, what you do is you break the population into natural clusters so that each of the clusters are really easy to go in and survey. What are the natural clusters at a college? It's really natural.
Do you mean like friend groups or?
Really, the ones that are really easy, just go in and ask everyone in that cluster and find that cluster too.
A class?
A class,
Okay.
yeah. So you go to this thing right here, the schedule of classes, and you go find a bunch of classes and you try to make it representative of the population. So you might want to choose, an online class, maybe a night class, a transfer class, a pre-transfer class, a continuing education class. So you choose classes that are representative of the college, and then you go into those maybe 10 classes, and then you go in and survey everyone in the class. And the good thing is that when you go into a class and survey, especially if the professor is doing the surveying, the students are going to answer. And it takes care of voluntary response bias, because everyone that you ask is going to answer the question. Okay, it also makes it a lot easier to deal with. Another example of clustering might be, let's suppose you want to do a study on best practices in nursing care. So you want to ask nurses throughout California, say, for example, how long a break they need to be effective. Okay, because you certainly don't want to make a nurse work 12 hours without a break. Okay, I do not want to be a patient who has a nurse working on me who's been working for 12 hours without a break. Would you? Yeah, I actually had a friend who killed someone that way. It was really awful. He was a pre-med, and he had been working more than 24 hours without a break, and he fell asleep while when he was supposed to be holding on to the heart valve thing. He killed someone. He felt awful. But it wasn't his fault. It was the fault of the person who made him work for more than 24 hours without a break. So the question is, how would you figure out how often you need to have breaks for the average person? Okay, there are thousands of nurses in California, right? And you can't ask them all. So cluster sampling is a good way of doing that. What you can do is, what are the natural clusters for nurses?
Hospital?
Yeah, hospitals. Okay, so you might want to identify some hospitals, and maybe you can identify, a few hospitals in cities, maybe a couple rural hospitals, different kinds of hospitals, some public hospitals, some private hospitals. I'm not a nurse, so don't ask me to be an expert in, what kind of hospitals there are out there. But the person doing the surveying would probably be the expert. And then you go in and you survey the nurses in that hospital. And that's a lot easier than like randomly good luck trying to get a list of every nurse and trying to go from hospital to hospital and the 500 different hospitals that you picked and do one nurse each, right? That would be a disaster in terms of your time. Does that make sense? But clustering is pretty good. You don't have voluntary response bias because you can go in and, especially if you can get the hospital administrator's permission, and you can bribe that person legally, give them some money, and say, here, I'm going to support your hospital with a little bit of money. Can you encourage the nurses to answer my question? And maybe we'll give the nurses some money too. Okay, that's a typical way of preventing voluntary response bias, is giving money. And then you go and you survey those nurses. Does that make sense? Okay, and that's a good way of doing it. Let me give you another example of sampling that I was involved in a couple years ago. It was one of my former students who ended up getting a business. And what he did is he made towels. Sorry if it's not that exciting, but you know, it was my student. And he made towels for hotels. And he was a big towel manufacturer. And he wanted to show that his towels were better than the ones made in China. So, you know, he makes tens of thousands of towels and distributes them all over the country. Okay. So he wanted my help in how to identify a sample of towels in his warehouse or his factory so that it's representative of the towels in his factory. Because if you choose all the towels that are made at a certain time, then you're going to be biased on that employee. Do you see that? Because you're going to have that employee who's working at that time might be a better towel maker than the next employee that's working a different shift. Does that make sense? So what we did is we did what's called systematic sampling. So we identified that in the time period that he wanted to be looking at towels, they were doing like 10,000 towels that they were making. So what we did is we picked every 1,000th towel that came off the assembly line and pulled that towel out and literally put it in the wash 100 times so that we could find out how it did after getting that kind of washing to find out if it got frizzled and all that. I'm not a towel expert. I let him deal with that part. But my contribution was helping him come up with a way of getting a representative sample of his towels. And if you're doing every nth towel, for example, then that is called systematic sampling. Any questions on that sampling technique? Okay. It would not work for, say, Americans. If you wanted to survey 1,000 Americans, why can't you do systematic sampling? Any thoughts? Why? What will go wrong? There's something that'll go drastically wrong if you try to systematically sample Americans. It's two things, actually. Any thoughts? Okay, here's the problem. How are you going to get a list of every American? Right? Because you need to take every millionth American or something like that, right? That means you got to order them. Well, how are you going to get a list? You can't do that. Does that make sense? It's not possible. It's not legal. You just can't do it. So systematic sampling only works in certain situations when you can actually get a list of everyone. It can work in businesses because you can ask, say, every 100th person who comes into your business. And that you can do. But it doesn't work in big populations like that. It doesn't work in biology, for example. Because what does it mean to list every tree in the forest? Good luck. Does that make sense? So if you can't list everything, you can't do systematic sampling. Okay, so those are the sampling techniques that I wanted to cover and talk about. Any questions on these ideas? Okay, by the way, there's a lot of language in this class, especially the first week. So be ready for it. Be ready for it. There's a lot of vocabulary. And you're responsible for understanding it and writing about it. Okay, so the next thing I want to mention is a couple things. One is different kinds of variables. And this is really important. And something I never really understood is why students have trouble with it. Okay, so if I asked you, let me ask you, how far from Lake Tahoe Community College do you live? Put it in the chat box if you can. How many miles from Lake Tahoe Community College do you live? And guess, I don't need to know the exact amount. You don't have to Google search it, but just guess. So put it in the chat box. How many miles from Lake Tahoe Community College do you live? I live, by the way, 0.8 miles from Lake Tahoe Community College. I know it very well because I've lived there for a long time and I've worked here for a long time. Okay. What I want you to notice if you're looking at the chat box is what you are seeing are numbers. I know this sounds really dumb, like, of course. Because the answer to the survey question are numbers, the data that you're collecting are a bunch of numbers, we call that quantitative. Okay? We are going to be splitting this class into two main topics. One is quantitative. Anyone know the opposite of the word quantitative?
Qualitative.
Yeah, qualitative. Okay? So qualitative is a whole different kind of survey question. And the way you deal with the data is very different when you have qualitative. With quantitative, you have numbers. When you have numbers, you can talk about the mean, which is the average. You could talk about the standard deviation, which I'm going to get to. You could talk about all kinds of numerical things about it. With quantitative, the only thing you can really talk about is proportions. What proportion of the population had that answer? So qualitative is things like, what state were you born in? If I asked you what state you're born in, put in the chat box what state you were born in, or country, if you weren't born in America. Everyone was born somewhere? Okay. Okay, do you see any numbers there? No. So this is a qualitative survey question. So promise me that for every problem for the rest of this class, the first thing that comes to your mind is this quantitative or is this qualitative? It's really easy to do, but it has to be in the front of your brain or you're going to be so messed up. Okay? It'll destroy you in this class. Any questions on that? Okay, for quantitative, there are two kinds of quantitative. I'm going to get into them in more detail. We have a whole chapter on this, 2 chapters actually. One is called discrete, one is called continuous. Discrete means that you can list all the answers. So for example, how many siblings do you have? Okay. Can you list all the possible answers of how many siblings a person could have? What do you think? Could that be done?
Yes, it can be done.
Yeah. Okay. Right? You could have, including yourself, you could have 1 sibling, right? You could have 2 siblings, for example. Can you have 3 million siblings?
Could.
No, you can't. It's not humanly possible. Okay. Can you have 4.5 siblings?
No.
The answer is yes, and I do. That's me. I have 4.5 siblings. Do you know what that means?
Yeah, I have a half sister.
Yeah, me too, Laura. Your half sister may not be named Laura, but my half sister is Laura. I don't know what your half sister's name is, but you can have half. But what you can't have is 3.1572 sisters. Does that make sense? You can only have a half sister. Okay, you can't have any kind of real number sister. So now I'm getting mathy on you. Okay, so if you can list all the possibilities, we call it discrete. If you can't list the possibilities, we call it continuous. Another way of checking is grammar. If the question is how many, then it's discrete. So how many siblings do you have? That's discrete. If the question is how much, then it's continuous. Okay, so how much do you weigh? Does that make sense? Okay, how much time did it take for you to shower this morning? Not how many time did you take to shower. Does that make sense? So how much time did it take to shower? You could have, for me, I showered 15.372 minutes. Okay? And that's possible, right? You could shower any real number of minutes. Okay? Okay, in a limited amount of time, but you can't list all the possible numbers. So that's called continuous. Any questions on the two types of quantitative? Okay, for qualitative, it's interesting. The book doesn't go into it as well as it should, but for us, there's going to be two classifications. There's the yes/no question, and then there's everything else. So things like, is this the first Lake Tahoe Community College class that you've ever taken? Okay, that's a yes/no question. Do you agree? You can't say, kind of. It is or it isn't. Does that make sense? So if it's a yes/no question, we're going to classify it different than if it's all the rest of them. And we're going to have whole sections on yes/no questions. And we're going to have a whole chapter on the other kind. So that's just to let you know, I'm giving you some vocabulary. There's not much to it. Any questions on that? Okay, now that we have all of that, what I want to do is I want to share my desktop, and I want to collect some data, and I want to do some statistics. I want to analyze it a little bit. So let me do that, and let's go share screen. And I had it. There it is. What? Oh yeah, the college hasn't given me a license yet. Just a minute. One more try. Okay, so what you're looking at is the TI-84 calculator. And remember, you're going to need one at least for the midterm and for the final. Okay, some webinars I'll use this, some webinars I will use the spreadsheet program. Okay, and I'm going to ask you a survey question so that we can actually get fun data. So I want you to put in the chat box. Let me ask you, it's one of my favorite survey questions. And the answer is you have to answer. You don't have to tell me the truth, but you have to give me a reasonable answer if you're going to lie. Got it? What age were you when you experienced your first passionate kiss? Okay? If you never have, just tell me how old you are. And if you don't want to tell me that, just give me a number. I just need numbers. Got it? Okay. All right, so let me show you how to do this in the calculator. So the first thing, and if you have your calculator with you, follow along. You go to Stat, and then Edit. Then I'm going to go and use my right arrow, go to L1. I'm going to hit Clear, and hit Enter. Let me give you a very important warning. See this button, Del, delete? Don't touch it. Got it? If you accidentally hit delete instead of clear, you've destroyed your calculator forever. It's one thing that TI people should never have put there. Okay? Or you're going to have to, you could reprogram it, but you're probably not programmers. Okay? You can come to me and I'll help you with it. But it's really, really challenging to figure out how to fix it. Okay? It'll ruin this first column, and you need the first column for the whole class. So don't touch that delete button. You got it? Clear, not delete. Okay, then what we do is you put in your numbers. So what we have is 16, and then 14, and 13, and then 16, and then we have 13. Okay. It's interesting. I've been asking this question since I started teaching like over 20 years ago. Any guess on, do you think that the ages have gone up or down? on average, statistically?
Down.
Up.
Hmm.
Up. Older generations kiss much younger than newer generations. Okay? And I've noticed that in all my statistics I've taken. I've actually read some journals, and they've said the same thing about their studies. Yeah, there's a lot less sex going on than there used to be among young people. Okay? I'm not going to tell you whether it's good or not, but it's definitely true. Okay? Okay, kissing and sex is just different than it used to be. Okay? So, interesting stuff. Okay, now that we have our numbers in, we're going to hit the stat button again. Then we're going to go to calc. And we want one var stats because we have one variable. The variable is how many times, what age were you when you got your first passionate kiss? Okay, later in this class we'll have two variables. Okay, then I'm going to hit enter. And there are two kinds of TI-84 calculators. If you have the other type, watch the other video and it'll show you how to do the other type. So the list needs to be L1. If it doesn't say L1, you go second, 1. And that gets you L1. Freq list, leave blank, because this is not a frequency table. I hit enter on calculate. Okay, so that's going to give us what we call statistics. Okay, so you might guess that that's probably important since this course is called statistics. So we need to understand what these mean. I'm going to tell you the ones that are important for this class. So this first one, see the X with a little bar on top of it? So the formal mathematical way of saying this is X bar. Okay, mathematicians aren't that creative. So we call it X bar. And what this is it's the mean. Okay? Also called the average, but in our class, I want you to use the word mean. Got it? So on the project or anything else, I will take off points if you use average instead of mean. Got it? Okay. There are two kinds of means. There is a sample mean and there is a population mean. Okay? And they are what they sound like. If the data you collected is a sample of the population instead of the whole population, then it's the sample mean. If the data you collected is the whole population, it's the population mean. Got it? If you collect everyone, we call it a census. Okay, and that means you asked everybody. That's actually in our Constitution. Every 10 years, we have to have a census. Do you know about that? It's going to happen in 2 years. So every 10 years, we have a census, and we have to do data about the population. So in this case, there's actually two ways of looking at this. We can think of this as a sample, or we can think of this as a population. So we can think of this as the population of people who attended this webinar. You see that? Because we asked everybody. Or we could think of this as a sample of students in the statistics class, because you're not everyone in the whole class. So it's perception. It's one of the weird things about you're used to math classes being this is or this isn't, but perception's important. So are you thinking of it as a sample of the big group, or is this everyone? Okay? If we're thinking of it as a sample of the big group, then we use X bar. If we're thinking of it as a sample of the population, we use the letter mu, kind of like the cat sound, mew. You know, I have a cat too. I think I saw some with a cat in one of the webinars. So it's mu, and the way you write it, this is my first time I've ever done this. Let's see if it works. Annotate, and let me go to draw. See if this works. I've never done this before. Do you see it? That's the way you write mu if it's the population. It's kind of a little U with a tail. It's a Greek letter. And that means population mean. Okay? And it's the average. You've known about that since, I don't know, 4th grade or something, right? Okay. The next two, don't worry about. We're not going to touch it. So the sum x squared, there's a lot of math involved in this class that we're not going to do. And this is some of the more intense math we're not touching. The next one, though, is really important. It's S and the sigma. They kind of go together. Those are called the standard deviations. And as you might guess, there's two of them. One is the sample standard deviation. That's S. And the other is the population standard deviation. Anyone speak Greek? Anyone know what that letter is?
Sigma.
Yep, that's sigma. The population, the standard deviation, whether it's sample or population, tells you how spread out the data is. So notice that the standard deviation for, let's consider this a sample because that's more likely that we're going to be doing samples, is about 1.5. So that says that the average dispersion, it's kind of an average distance from the mean, from 14.4 years old, is 1.5 years. So if you have people all over the place in when they got their first kiss, then you're going to have a larger standard deviation than if most people all had their first kiss at the same age or close to the same age. Does that make sense? So that's called the sample standard deviation. Okay? And then population is if it was the whole population. Okay. Any questions on that? Okay, so if we added one more person who said that they had their first kiss when they were 14.4 years old, would the standard deviation go up or down, or stay the same?
It would go down.
Yeah, and why would it go down?
Because the average, because the median is 1.5.
Yeah, 14.4.
Oh, yeah.
That is the mean,
Yeah.
right? The mean is 14.4, and we just added someone at the mean, so now we have more that are close to the mean. Do you see that? So the average distance from the mean is going to be smaller because we just added a 0 from the mean. Do you see that? All right. What if we pop someone in there who was 5 years old when they had their first passionate kiss? That's just disgusting, but let's suppose. What would happen to the standard deviation?
Go up.
It would go up because we put someone far away from the mean, and if they're far from the mean, that means the average distance is going to be bigger because we have more spread out data. Do you see that? Okay. I usually ask this on test too, this kind of problem, and it's not that pretty either. So I will let you know when something's real important and I test on it. So take a note about it. Be ready for it. Okay. I don't give you trick questions. I give you questions that ask things that I tell you I'm going to be asking. Got it? It won't be about first passionate kiss, but it could be about some other thing that I asked. But
You're going to test whether if whatever caused the standard deviation to go up or down?
Yeah, I often do that. Okay, and talk about, do you understand what the standard deviation is all about? Do you have numbers close to the mean or far from the mean? If your numbers are close to the mean, you have a small standard deviation. If your numbers are far from the mean, you have a large standard deviation, and far on either side. Got it? Any questions? Any questions on the standard deviation, on what it does? Okay. Some of the other numbers are obvious, I hope. N equals 5. What do you think that is?
Number of people or sample size?
Yeah, that's just your sample size. How many people we asked? Okay. And you don't need a computer to figure that out. But you should know we always use the letter N for sample size. That will be reserved for this entire class. Min X, you better understand that. That means the lowest. Q1, that stands for first quartile. And what that basically means is that 25% of the population, of the sample that we asked, is at or below 13 years old for their first kiss. Does that make sense? So we're breaking it into force. So that's where the cutoff line for the bottom fourth is. Does that make sense? Typically, you have larger samples. When you only have a sample size of 5, it's hard to even think about cutting into fourths. You should never do a sample size of 5, but that's all we have here. So you should do larger samples. Okay, let me scroll down. And I need to unannotate. See if that worked. Good. Okay. Med. That's not Club Med. Anyone figure out what that might mean?
Median.
That's the median. And the median, again, you've gotten this in grade school probably. That's the middle number. Okay? And if there's an even number of numbers, it's the average of the two middles. Does that make sense? So that's what the median is. The median is a better representation of the typical thing than the mean. So when have you heard the median used? In what situations have you heard median instead of mean? In the real world. Don't tell me you never heard it.
Like a house price or something?
Yeah, home prices. So let me give you, I know you may not know Tahoe, but if we looked at the average home price, then the average home price is going to be probably $1 million. And if you've been to Tahoe and you've seen some of these houses that are sitting on the lake and they sell for $50 million, what's going to happen is that is going to skew the mean so far up high that your average is not going to be your typical anymore. It's not going to give you a representation of what your typical person lives in. Does that make sense? The median is more of your typical house. Okay? The average, though, is important because let's suppose you are my friend Wendy. My friend Wendy is the mayor of this town. Good thing about a small town is we know everybody. And she cares more about the mean because what she cares about is how much money comes in for taxes for the city because she's our mayor. Does that make sense? And that $40 million house is putting in a lot of tax money into the county, into the city. Does that make sense? So that would be a situation where the mean would be more important. So it depends on what you're interested in whether you care about the mean or the median. Got it? Okay, the next number is Q3. Here's a thought. If Q1 was that cutoff line for where the bottom 25% is, any guess on what Q3 might be?
The top 75% or the top 25%?
Yeah, it's going to cut off where 75% is below that number. So that's going to be that high quarter. Does that make sense? So Q stands for quartile, and Q3 is the high quartile. Q1 is the lower quartile. And if you take Q3 minus Q1, we call that the interquartile range. So in this case, the interquartile range is 3. Any questions on that? And that's another measurement of how spread out the data is. So standard deviation is one measurement, interquartile range is another measurement. The other thing you can think about is in between 13 and 16 is going to be where the middle half lie. So if you want to advertise to the middle half, then you're going to be going in between those who got their first kiss at 13 and those who got their first kiss at 16. So if you want to go in and make sure you educate kids about sex education, then 13 to 16-year-olds might be where you're going to go if you want to grab the people that are just going to be first experiencing it. Does that make sense? And that'll be your middle half. Okay? Whereas if you want to grab the people that are the very, very youngest, then you're going to be looking at just 13. Does that make sense? And because the first quartile and the minimum are the same, that means at least 25% were all 13 years old. Does that make sense? Because we can see that. You won't usually have the same number for any of these. But in this case, we had it. Any questions on understanding these statistics? These are called statistics because they're numbers about a sample. If they're numbers about a population, we call them parameters. Okay, I'm not going to make you calculate these by hand. I am going to make you know how to use a calculator to calculate these. Sound fair? Okay, or a spreadsheet, but calculate it for the test. Any questions so far? Any questions? Okay, one more formula I want to give you, which is the one formula actually you need because the calculator doesn't have it. Let me annotate it so that I can, where am I? More, where was it? Annotate, there we go. And that is Z. So Z is called the Z-score. And what the formula for Z, it's not very hard, but it's important. You can stick it on your note sheet if you don't want to have to memorize it. It's X minus the mean. And that mean might be X bar, but I'm going to write mu because pretend we have the population. If you know the population, use sample data divided by the standard deviation. And what that tells you is how many standard deviations you are from the mean. So, question?
Are we going to have to calculate that by hand?
Yeah, because the calculator doesn't, well, you can use a calculator, but there isn't like a Z button on your calculator.
Oh, okay.
On this list, there is no Z.
Okay.
When I say by hand, it means you're going to have to hit the buttons.
Makes sense.
Okay, so X is going to be the value. So for example, what is the Z-score if you happen to be 20 years old when you got your first kiss? Well, how do we do that? Well, we go 20 minus the mean. And the mean, if you remember, was 1.4. Sorry, it was, what was our mean? It's up there somewhere. Do you remember what it was? 13.4 or 14.4?
14.4.
14.4.
Wait, so mu and X bar is the same thing then?
It's not the same thing. One's population, one sample. You use whatever you have.
Oh, okay.
Okay, whatever you have is what you use. If you have the population, which you usually don't, then you use the population. So they both mean mean. Divided by, let's use our sample standard deviation because that's more typical, 1.5. I want to give you a note about rounding. If on the written test, on the midterm and the final, I don't really care. You should use the rules of rounding, but I don't care if you use 2 decimals or 3 decimals. It should be somewhat reasonable. Don't use 1 decimal. I mean, don't use 1 significant digit and round to the nearest 100 and just say it's 0, because that's silly. But just do a reasonable amount of rounding. On your assignments that you have online, you do whatever it tells you to do. So if it says round to 4 decimal places, you must round to 4 decimal places. Got it? Okay? And don't do rounding until you're done. So normally you're going to put in this big long number into your calculator. But I didn't want to write it all out. So then you calculate 20 minus 14.4 over 1.5. And don't forget, I want to give you a warning. A lot of people make this mistake. Is that when you put in your calculator, you need parentheses around the 20 minus 14.4, or it won't give you the right answer. Because it's going to do order of operations, whether you want to or not. And division happens before subtraction unless you use parentheses. Do you remember that in order of ops? Now it's starting to feel like a math class, isn't it? So what do you get? I'll let you put in the calculator and tell me what you get.
$3.73.
3.73. Okay, so that is actually a very large z-score. So if z is greater than 2 or less than -2, we call the value an outlier. If z is greater than 3 or less than -3, we call it an extreme outlier. So this value, 20, is an extreme outlier, okay? Which means that it would be a very, very rare occurrence, okay, for somebody to wait till they're 20 years old before they had their first passionate kiss. Does that make sense? So that's called an extreme outlier. Now, our sample size is small, so we can't say a whole lot. But if you had a larger sample size, then it definitely would be super, super rare. Does that make sense? So outliers are important. When you have an outlier, you have to make a decision. And the decision is, was this a mistake or was this just a really weird person? Does that make sense? So if you asked, how old were you when you had your first passionate kiss? And someone said 372, what would you say?
That's
Bullshit.
a mistake.
It's a mistake. Do you see that? And then what you do is you don't put that in your data set. Okay? But if they said they were 20 and they looked like they were being honest, then that might just be true. Do you see that? And they're an important person and you want to include it. Okay? So you always want to look at your data and decide, is a number even reasonable? If it's unreasonable, you just get rid of it. Okay? If it's large and reasonable, like you don't think the person lied or made a mistake or switched the numbers, 14 became 41 because they were dyslexic or something, you have to make that decision whether to keep it or not keep it based on outliers. Any questions on that? Outliers influence the mean. Outliers influence the standard deviation. Outliers do not influence the median. So if we had a survey of 1,000 people of first kiss and someone said 300, that's going to raise the mean by a lot. Does that make sense? But the median won't raise by much at all. Does that make sense? Because the middle person isn't going to change much. Does that make sense? Is that clear? So you want to look to see what is influenced by outliers and what is not. The median is not, the mean and standard deviation are. Is that clear? Okay, very important. Any questions on all of these statistics? So was I right? The second part is starting to look more mathy than the first part? That's kind of how it is. Okay, the last thing I want to talk about before we say goodnight is graphing. Okay, is graphing. I want to not do it by calculator because calculators aren't that good for graphing. I think I want to do it. I'm going to draw some graphs. I'm going to sketch some pictures. And to do that, I want to unshare Metasktop. And I want to reshare with Paint. Sound good? Because that's a good one. And let's go screen share and Paint. Wrong one, that one. And let me, shoot, lost it.
Just out of curiosity, because I joined late, did you say the secret word yet?
Not yet.
Okay.
I just realized my Paint's on. I'm on a dual screen and the Paint's on the wrong screen. There we go. And now I can share. But I will get to the secret word. I often do it at the end, but not always. Share screen. And let's go to Paint. Okay. So let me show you some typical graphs that you need to understand. The first is a histogram. And let me just do a drawing. Let me go over here. And also I need to set up, just in case you're using it. Good. Just want to make sure I can see the chat. When I share a screen, it kills the chat. Okay. So now we can draw a histogram. And you've seen histograms before. I'm doing my best. I'm using a mouse to draw these things. So that's an example of a histogram. Okay? They should be rectangles, by the way. I'm just, as you can see, I did not major in art. So I apologize if it doesn't look beautiful, but I do my best. Okay, this is an example of a histogram, and a histogram has a few features. One is the x-axis has to be quantitative. Otherwise, it's a bar chart, not a histogram. Okay, so if the x-axis is quantitative, we can do a histogram, and each box needs to be the same width, and the height of the box represents the frequency. Okay, the one I drew right now, we call this skewed right, because we can see the mode, which is the highest frequency. Highest frequency is not the same thing as majority, by the way. The highest frequency is on the left, and then there's a tail on the right. So we call this skewed right. Any questions on that? And let me give you another example of a histogram that's not going to be skewed right. So here we have the highest frequency in the middle. Do you see that? And then from the middle, it goes down on both sides. And it looks kind of like a bell curve, doesn't it? Except we're not going to use the word bell curve in this class. We're going to use normal. Okay? There's a few words for it. The middle technical word is normal. The least technical is bell. And the super technical is called Gaussian, which I'm not going to get into. There is actually a formula for this curve, and it's 1 over the square root of 2 pi times e to the negative x minus mu quantity squared over sigma squared. I said it fast because I don't want you to memorize it. Are you glad I said it fast? But that's there is a formula. There's an equation. And it's exponential and with the weird exponential stuff going on. But the important thing is it's symmetric. The mean is in the middle. The mean and the median are the same. And it looks kind of bell-shaped. And they call that normal. Normal is the most important distribution we have in this whole class. Okay, and it has this shape. Another distribution that is another pretty important distribution. I'm going to do my best drawing it. What do you notice about this one?
It's flat.
It's flat. Every box is the same. And the word, we don't use the word flat. We have a different word for it. It's called uniform. You wear a uniform in school so that you look the same as everyone else, right? So if every box has the same height, we call it uniform. Okay, and that's a uniform distribution. So this, by the way, I showed you skewed right, normal, uniform. There is skewed left. I hope you could figure out what skewed left would look like. Any guess?
The tallest bars on the right, I'm assuming.
Yeah, I'm going to call it the mirror image of the skewed right is the skewed left. Got it? So those are the distributions you need to understand. Any questions on this? So notice that for the uniform and the normal, the mean and the median are the same. Because I like to think about the outliers as tugging the median. But in the normal and the uniform, the outliers on the left and the right, and it's a tug of war and it's even. So the mean doesn't get tugged at all. Does that make sense? Stays in the middle. On the other hand, if it's skewed left or right, so if it's skewed right, the mean will be larger than the median. If it's skewed left, the mean will be smaller than the median. Any questions on that idea? Okay, so these are histograms. The other plot I'm going to talk about is the following. Let me draw one. So now we're not going to do histograms anymore. It's going to look kind of like a bomb. at least to start, and now I'm going to change it. The interesting thing is, if you're young, you might know what this plot is. Anyone seen this? Huh?
Box and whisker.
Yeah, this is Box and Whiskers, because now every high school student gets it. Did you get into high school?
Yeah.
Yeah, every high school student gets this. My generation, okay, and not just my generation, but anyone who went to high school more than 3 years ago, most of them did not get Box and Whiskers plot. It's like new in the curriculum. Okay, you still might have, but if you just went to regular high school and had just algebra and geometry, they typically did not teach Box and Whiskers, but now they are. So it's become standard. So it's going to be interesting. I think in 10 years, I'll be teaching this, and just about everyone's going to already be an expert on it. So what this is, we call this a Box and Whiskers chart, and it is a 5-point summary chart. And let me tell you the 5 points. It's the ones we've already talked about. The one on the left is the minimum. Okay, so the one on the left is the minimum. Let me write minimum. This next one here is Q1. Remember what Q1 stands for?
First quartile.
First quartile. Remember that? This one here is the median. I'll just call it M for median. The next one is Q3. And the last one is the max. So if you want to give a 5-point summary of these things in a picture, this is how you do it. Okay, you got to be careful about general audiences, because if you show this to a general audience, they'll have no idea what you just drew. Most general audiences understand histograms, but they don't understand Box and Whiskers plots. So for educated people in statistics, they know Box and Whiskers plots, and for younger people now, they know Box and Whiskers plots. It's kind of interesting. It shows the interquartile range really well. That's one of the big ones. You can really easily see what the middle half is in a picture. Does that make sense? So it's used for some things. You cannot look at this and know if it's normal or not, if it has a normal bell-shaped or not. Does that make sense? Okay, so it has pros and cons, just like a histogram has pros and cons. Some other charts I'm not going to be doing, but you should know just from like basic knowledge, is pie charts. You guys all know what a pie chart is, right? So I'm not going to go over that, but you should know what a pie chart is. You should know what just a regular old box plot is. I mean, what a regular old bar chart is. You know, things that you've been seeing forever. So I'm not going over the details of that, but you should know what those are. But I wanted to give you some of the very specifics. One more, I don't have time to do the full thing, but I'll let you watch the video on it, is called Stem and Leaf. And I personally use it for grades. So what I do is I draw a little T-table where the left-hand side of the stems and the right-hand side of the leaves. So my grades might be in the 50s, the 60s, the 70s, the 80s, and the 90s. So if someone scored a 52, I put a 2 right here. If someone else scored a 52, I put another 2. If someone scored a 61, I put a 1. If someone scored a 68, I'll put an 8 here. If someone scored a 70, I put a 0 here. Do you see how that works? And I could get I can get kind of 2 things out of this. One is I can get the shape of the distribution. Because if there are a whole lot of 70s, the 70s are going to come out, and I'm going to see that curve. The other thing is I can go back and know exactly how everyone did exact values. Whereas with the histogram, you only know ranges. You don't know exact values. And with the Box and Whiskers, you really don't know anything about exact values. So the stem and leaf plot, you know exact values, and you can get the shape. Some of the issues with stem and leaf plot is if you had 1 million values, you can't do it. Too many numbers to put on a piece of paper. you see that? Because you have to be able to put every number on. So that's a problem. The other thing is if you're presenting and you have uneducated audiences, they won't understand what you just did. So it doesn't work for general audiences, but it's really nice to get an idea of like how many A's, B's, C's, D's, and F's I've got in my class. Do you see that? I hope I don't have any of these in the 50s and 60s, by the way. Okay, but I can look at it. And that's called a stem and leaf plot. Okay, and you can choose what your stems and leaves are. So I chose here my stems to be the tens and my leaves to be the units. I could choose, say, units for the stems and tenths for the leaves. Does that make sense? So if everything was in between 0 and 9, and I had 1 decimal place of accuracy, then I could let the decimal place, that tenth digit, be the leaves. So that's up to you on how you want to call it. Does that make sense? Any questions on all of this? Okay, the final thing I want to do, what I've not done yet. What have you not seen yet?
Word.
Secret word. Oops, that's a little too big because I won't have room for it. And the secret word for the day is statistic. Because we have spent a lot of time talking about the individual statistic. The mean is a statistic. The standard deviation is a statistic. The range is a statistic. The minimum is a statistic. The maximum is a statistic. The first quartile is a statistic. The third quartile is a statistic. There are a lot of different statistics that we've talked about. So I think I try to make the secret word something that you may not guess, although this one you might have guessed, but is an important part of what we did in the daytime, in the lecture. So the way I always do the webinars is I will answer any questions you might have about anything. And I'm always happy to help you. And this is a big part of the webinar, is for you to be able to ask questions. Okay, whereas, for example, the long video, you can't ask questions while you're watching it because my YouTube self won't answer it. So if you have questions, in fact, I'm going to unshare my desktop so we can see each other and unmute you all. And also so that those who are watching on YouTube hopefully won't just go to the very end and write down the word. There's a little extra at the end. They'll have to go find it. But make sure you all write down the secret word. And if it lets me in, it doesn't let me unmute you if you've already muted yourself. But that way you can talk, because I do want you to talk. That's the whole point. If you have any questions, great time to ask them. And about anything from the course, I'll be happy to answer. Just a couple things. Make sure you're looking for partners now for your project. Okay, we're not quite ready to do everything from the project yet. Next week I'll start really talking about it. But your project is going to be to take you can do a study, you can do a survey using either stratified sampling or cluster sampling. And it's going to be one quantitative data set. We now have the vocabulary to understand that. And then you're going to do all the stuff that I just talked about with quantitative variables and do a full analysis of it. Okay? I'll talk about it in the next webinar in a deeper way. But right now you haven't practiced that stuff. So you just heard it for the first time. I want you to have a little bit more knowledge about it before you jump into the project. Any questions? Any questions? And I do want to remind you that I'm always looking, or I'm often looking at the discussion forums to see if you have questions there too. But if you're here, you should ask now. And there are nothing from the Q&A. There was a project one discussion, but it's probably not a question to me. It's probably looking for a partner. Yep, someone wants to look for a partner. So you should be getting partners in the next 3 or 4 days, hopefully. 3 is best. Any questions? Okay. Just make sure that you go to week 1's secret word quiz and type in the word that I gave you a little while ago on that secret word quiz, just to show that you got it, and then make sure you get the point. And that way you're done. You only do it once. It's really easy. It's the easiest quiz you've ever taken, I promise. So if you don't have questions, we'll say goodnight, but I'm also happy to answer.
Good night. Thank you again.
Good night. Have a good evening. And next week will probably be Monday at 7 is my guess, unless I see some Q&A forum questions, suggestions. But that seems to be what people wanted.
You said next week on Monday, not Tuesday?
Well, I like to vary it. So if we did Tuesday this time, I'll probably do Monday next time. So I have to go back and forth so I don't black out anyone who has can never make Tuesdays.
Okay.
There are requests to do 7 instead of 6. And again, I'm always listening for requests. But I don't want to make it the same time and day every week, or there'll be some people that can never make it.
Yeah. Is there anybody in here that doesn't have a partner?
I don't have one.
Perfect. Let's partner up then.
All right.
Okay. And if you can get a third person, that's even better.
Okay, can I join you?
Perfect. Yes.
Yeah.
All right.
Make sure you share. Make sure you write down each other's names. You can contact via Canvas, and then
Yeah, I think we're able to message each other as well through Canvas.
yeah, you can message through Canvas. If you're comfortable doing a Skype thing, you can do that. That's up to you. And however you want to communicate.
So when is the start? When are we supposed to be starting it?
So it's not due for a while. In fact, let me grab the syllabus because I don't have all the dates memorized in my head. But it is due. It's not due until May 6th.
Okay.
So that's a long time from now. So I would start getting partners now. And then I would probably start maybe next week.
Okay.
Okay.
Perfect.
Because right now it's the 10th. If you start next week, that's the 17th. And that gives you 2 weeks to do it. 2 weeks is plenty of time. Okay.
Alrighty.
That's my suggestion. Any other questions?
I'm good. Thank you. Have a good night.
You too. Have a good night. And again, just hit the leave meeting if you feel like you're good.
All right, good night.
All right. Good night. And for all of you who are watching this as an archived YouTube video, thanks for watching. Don't forget to find the secret word and put it into the secret word quiz for this week. And also, when you have questions, please post on the Q&A forum for questions about anything except for the project, and that you would post on the Project One discussion forum. And I'll be happy to answer. So have a great night or day or wherever you are. Thanks.